Hello Math 141. Today we're going to take a look at number 35 from page 174 of your textbook. I'm going to read this since I won't have enough room to actually write it all out on the screen, plus it would take too much time. So if you need to either A, refer to your textbook, again that's page 174, number 35, or what you can do is go ahead and just rewind the video and listen to the narrative for the problem. So number 35 reads, you have a wire that is 56 centimeters long. So in certain instances, it's always good to maybe draw a picture and label it. So from this end to this end, this is 56 centimeters in length. You wish to cut it into two pieces. So I'm randomly going to put a cut maybe right there. One piece will be bent into the shape of a square. The other piece will be bent into the shape of a circle. Let A represent the total area enclosed by the square and the circle. What is the circumference of the circle when A is a minimum? So again, if you need to, please go ahead and rewind the video, and we will go from there. But if you're ready, we're going to go ahead and start labeling some items on the drawing. So I've cut this into two pieces. So one piece I'm just going to call X. I don't know how long that piece is, so since I have an unknown, that's what variables are for. We use a variable to represent an unknown value until we can kind of discover what it actually is. So if this piece is X, then the other piece has to be the total length of the wire minus the piece that we identified as X. You know that you're on the right track, so if you did X plus 56 minus X, that would total to 56 again, because one of these X's is positive and the other is negative. So if you added those together, they would cancel each other out, leaving you the 56. Okay, so I'm going to kind of be pretty strategic about this. So this length of wire I'm going to use to make my circle, and this length of wire is going to be my square. Alright, so far so good? Alright, so what do we know? Basically what we want to do is we want to deal with perimeter first before we get into area. The perimeter is going to allow us to know the measurement of the circle, the circumference, and then the perimeter of the square. So I'm going to start off with the square first. So I apologize for the sloppy handwriting. Alright, so for the square, we know that the perimeter is going to be equal to the sum of all four sides. We also know that all four sides are equal to each other by definition of what a square is. So in this case, the perimeter would be equal to that 56 minus X. Okay, so the side of a square would be equal to 56 minus X divided by 4. So I'm taking that full perimeter of the square and dividing it into 4 equal pieces, because again, all 4 sides of a square are equal. Okay? So from here, what we can kind of go ahead and do is we can clean this up if we want. So 56 minus X divided by 4. Basically what I'm doing is I'm rewriting it so that each term, so the 56 and the X, will have that common denominator. What you're seeing on the left-hand side here that I'm boxing is kind of the shorthand. Since they both have the same denominator, I write both terms under one denominator. I can also go ahead and split that up. They mean the same thing, hence the reason why I have an equal sign between these two expressions. So finally then, 56 divided by 4 would be 14, and this would be minus, let's rewrite this, so instead of X over 4, we'll do 1/4 times X. Okay, X over 4 and 1/4 times X mean the same thing. Okay, if you're a little unclear on that, please come and see me about that. Now we actually have enough information to talk about the area of the square. what is the area for a square? How do I determine that? This is very kind of Blue's Clues, like a Nick Jr. Sesame Street, because now I'm going to say very good if you said that this is length times width. Well, we know that the length and the width of a square are equal to each other. So this means that this is equal to 14 minus 1/4 x times 14 minus 1/4 x. And if I'm feeling particularly neat about things, I can kind of shorthand this and say, well, this is 14 minus 1/4 x squared. Okay? So far, so good? Okay. If you actually want to FOIL this out, so whether working with this representation or this representation, if we FOIL this out, and feel free to double check my work, we get 196 minus 7x plus 1/16 x squared. So if you kind of look at it, it looks like I have it in standard form, but I have it going in ascending order instead of descending order. You could have also written it like so, 1/16 x squared minus 7x plus 196. Either representation is correct, okay, for what we're trying to do. So I'm just going to divide the wall, if you will. So now I'm going to talk about the area for the circle. So the special thing about an area for the circle is that it's called the circumference. And if you recall the formula, so we know that the circumference of the circle will be equal to x, because that's the measure of the wire that I use to form the circle. And I know that the formula is going to be 2 times pi times r. And really what we need in order to find the area of a circle is the radius. So my whole focus is going to be on r. So I want to get the radius on its own. So what I'm going to do is divide both sides by that 2 pi. So that side is clear and r is isolated. So we know now that r is equal to x over 2 pi, or again we can write this as x times 1 over 2 pi, or 1 over 2 pi times x. Okay, all three of these representations, again, let me stress to you, they all are the same thing. They're just written, they're just displayed differently. Okay. So now we have enough information to find the area for the circle. So I'm going to do A and with a little circle underneath it just to denote it. And we know that that is going to be, the area for a circle is going to be pi r squared. And we know what r is. So I'm going to go ahead and substitute that in. So now I have pi times 1 over 2 pi times x squared. Okay. If I evaluate this, I have pi times 1 over 4 pi squared x squared. Okay. Again, if you're not sure, expand that out. Do one. So here we'll do a little bit of an aside in pink. So what I'm doing is I'm trying to kind of think on the side here. So if I expand this out, I have 1 over 2 pi times x times 1 over 2 pi times x. So here's my x squared, and 1 over 2 pi times 1 over 2 pi would give you 2 times 2 is 4, pi times pi is pi squared, 1 times 1 is 1. So that's how we get that representation. So far, so good? I hope so. Okay, so if we clean this up, note that I have a pi in the numerator technically if I write that over 1. So one of the pi's will cancel here in the numerator, and one of the pi's will cancel in the denominator. And this leaves us with 1 over 4 pi times x squared. Okay? Alright, so what I'm showing you is actually, I'm doing all of this by hand. You could default to the calculator, and if you are going to default to the calculator, please come see me. But I also believe that this method was gone over with you in class. So I want to show you a different method. I'm going to show you by hand. Okay, this I think will kind of expel the why behind how these numbers and values are working. Okay, so again, to go back to the question, we want just capital A to represent the total area enclosed by the square and the circle. So in other words, A is going to be the area of the square plus the area of the circle. And we actually have all of those representations, right? So here's the area for the square, here's the area for the circle. Okay, so the area for the square is going to be 1/16 x squared minus 7x plus 196 plus the area of the circle, 1/4 pi x squared. Okay, so from here, I'm going to actually just shuffle things around, and I'm allowed to do that because of the commutative property for addition. So remember, commute means that we are allowed to move terms around and not change the intrinsic value of the expression. Okay, so again, kind of like, for example, 2 plus 3 is the same thing as 3 plus 2. So I'm going to group my 1/16 x squared plus my 1/4 pi x squared minus 7x plus 196. And what I want you to note, and again, it's something that easily slips our minds because we're so used to working with something more and more complex, we almost forget to use our tried and true tools that we pick up along the way in algebra. Notice that one term has an x squared and another one also has x squared. So what this permits me to do is factor out the x squared. So this is going to leave me with 1/16 plus 1/4 pi, and I factored out the x squared. And again, if you're not sure if this means the same thing, go ahead and distribute that x squared back to both terms. Okay, and then again we have like so. And what I want you to pick out here is that, do you believe that this is in standard form? And I hope that you do. So this number, again, these are all constants. These are all actual numbers that we are able to work with. There are no variables in here. This is our A in our standard form. Our -7 is our B, and our positive 196 is our C. So in order to find the maximum area, we will go ahead and we will find H. So H is -b over 2a. So I'm finding the vertex, because notice that, like I said, this is standard form, but more specifically, this is standard form for a quadratic equation. And since, if you notice, this quadratic equation does not have a negative in front of it, this is a parabola that will open upward. Okay. So I basically just need to identify, okay, my B is -7. 2 times my A, this is 1/16 plus 1/4 pi. Now you're probably going to need to get a little bit creative. This is where I would suggest defaulting to the calculator and helping you figure this out. If you are entering this into the calculator, let me show you how you would want to enter this, because you want to be careful. So if you're using your calculator, we would have 7, because again, in this case, we have a double negative, divided by, and then we're going to put a set of parentheses and do 2 times, and then you're going to have 2 sets of parentheses, one for 1/16 and close it, plus another one for 1/4 4 pi. So you're going to have quite a few parentheses here. Okay. There we go. Okay. When you clean all of this up, we get that H will be 24.634 centimeters. Okay, so here is your final solution. All right, so hopefully that kind of explained everything. Again, once you get to, I'm going to highlight this in green for you. Once you get to this step, you can actually go into your graphing calculator and graph it, and then use your minimum function in your TI calculator to help you find the solution that you're looking for. Okay? And again, just to reiterate, if you're still kind of hung up, like, why did I just need to find the x value of my vertex? Why didn't I need to find the y value? Well, notice again that at the very beginning of the problem, we called this x. So we're actually referring to an x value, so that's why we hone in or zoom in or focus on the x value of the vertex and not the y. Okay? So if you have any other questions, please let me know. I hope that this video was helpful, and I will see you in class.